Hi students, this is Neeraj Bansal and welcome back to my YouTube channel. Today we are going to work on planes. But before starting the topic, I would advise you to see the video completely. Don't try to skip in between because sometimes what happens when you skip in between is many, right? So let's not waste the time and start with the topic planes. Like when we did lines, we have said that there is an equation of a line, vector equation, parametric equation, and Cartesian equation. Same way, for the plane also we have a equation. What is a plane? This thing is a plane, and plane is a vector quantity, right? And the direction of the plane is perpendicular to the plane. So plane is vector quantity, and direction of plane is perpendicular surface. So in this, we have two types of equations. Number one is called vector equation of plane. And number two is called Cartesian equation. Here, Cartesian equation of plane is more important than vector equation of a plane. But we need to understand how to make the vector equation, right? So let's say in order to find vector equation, I need a point. Let's say this is point A, this is point B, and this is point C. That means I need three points making two vectors. Like in this case, I'm making two vectors, vector AB and vector AC. These should be non-parallel vectors. Got it? Right. So what is the vector equation of a plane? Let's call vector AB as lambda times vector B, because I said this is my vector B and is the magnitude, so lambda times. And let's call vector AC as mu times vector C. So basically here vector B is direction and lambda is magnitude. Same way, vector C is direction and mu is magnitude. Now we need to understand how it works. So it's simple. Vector R is equal to vector A plus lambda vector B plus mu vector C. So this is how we do it. This vector R is a general point, which is, let's say, x, y, z. Got it? And vector A, the coordinates will be q. Vector A, B, you can find by vector B minus vector A. And vector AC, you can find by vector C minus vector A. So this is called Cartesian equation. Then what is the, sorry, this is the vector equation. So what is the Cartesian equation? See, let's say there is any point A on this plane. And this is the direction vector of the plane. Let's call it, you can write it n cap or n. That doesn't make any difference. So this is the, what do you say? The direction vector. So I'll call it direction vector only. And I have a point. I want to find a general point on this plane, which is R, right? So in this case, this vector, this whole vector can be written as vector R minus vector A. Let's give it a small thing here, right? And this normal vector is vector n. So this is a general vector, and this vector n or n cap is equal to normal vector. So I know, let's call it point C. So it will become vector AC, right? So I know, we know this vector n is perpendicular to any line drawn on the plane. So I can say vector AC dot vector n is equal to 0. So vector n, vector r minus vector a is equal to 0. So vector n dot vector r minus vector n dot vector a is equal to 0. It implies vector n dot vector r is equal to vector n dot vector. So vector a will have some dimensions, right? 2, 3, 4, 5, 6, 7, or whatever. So let's take an example. If my vector n is equal to 4 and my vector a, that means this point which is given here is 5, 6, 7. So what will be my equation, right? So vector n is 2, 3, 4 dot x, y, z is equal to vector n, which is 2, 3, 4 dot vector a, which is 5, 6, 7. This will give me 2x plus 3y plus 4z is equal to 5 times 2, 10, 6 3s are 18, 7 4s are 28, right? This will become 2x plus 3y plus 4z is equal to 38 plus 18. How much? Let's check. 38 plus 18, right? It enter 56. Perfect. So this is 56, right? So this is called the Cartesian equation of plane. That means my Cartesian equation of plane is ax plus by plus cz is equal to d, right? D is some constant and ABC is your normal vector. I hope this is clear, right? So this is how will we make the equation. We'll do one question and you'll understand how to do this, right? Here. So find the equation of a plane with normal vector and which passes through the point. See, it's always better to make a rough sketch, something like this. So normal vector, that means this vector is equal to 1 and 3, and the point lying on the line, let's say this point is -1. I'll call it a is equal to -1 to, I know my equation is vector n dot vector a is equal to, or rather vector n dot vector r is equal to vector n dot vector a, which will give me vector n a is 1 to e 1 to, and e dot vector r is equal to x, y, z is equal to 1 to e dot vector a, which is minus 1, 2, right? To solve it, you will get x plus 2y plus 3z is equal to negative 1 plus 4, 2 times 2, 3 times 4, 12 plus 12. This will give me x plus 2y plus 3z is equal to 16 minus 1, 15. So this is the Cartesian equation of the plane. Let's come to another question. So I have to find the equation of the plane through A, B, C in vector form in Cartesian, right? So what we need to do in this case is, let's take this point as A, E, and C. Right. So first I'm making the vector equation. So this is vector B minus vector A. Let me call it vector D. Let me call it vector C. So my equation will be vector A, which is this point, vector A plus lambda vector B plus mu vector C. So let's do it over the calculator. I'll store these vectors as vector A, vector B, and vector C, and then I'll solve it, right? So you will understand also how to solve this by using the calculator, right? Let's see. So how to store it on the calculator? I'll just explain you. My vector A will be minus 1, 2. I'll take this bracket minus 1 comma comma 0, right, is stored this word s as A. Hit enter, right? So this is stored, this vector A is stored as vector A. Now I want to store my vector B, 3, 1, 1. I'll take this and then I'll put 3 comma 1 comma, right? Then I'll press again this store, and then I'll press D. Hit enter. Very good. Now I will again take this. Let me check. 103. 1 comma E, then store, then C, and then hit enter. Right. So this is stored. Now let's come to, so vector B is equal to vector B minus vector A. So what I'll do is B, now since I have stored, so I can do B minus A and hit enter. So vector B minus vector B is, so vector A plus lambda times 4, negative 1, 1 right? I can write this vector A as well. Vector A is negative 1, 2. I'll write negative 1 here plus mu times vector C. Mu times vector C. Vector C is equal to vector C minus vector. I'll write vector C minus vector A and then enter. 2, negative 2. So I have got my vector B. So lambda vector B. Vector B is equal to negative 1, 1. And vector C equal to negative 3. Now, we need to understand one thing. We need to understand that if this is my plane, or rather just if this is my plane, so this vector B cross vector C will give me the normal, because the cross product of two vectors is perpendicular to both the vectors. So I need to take the vector product, right? So menu matrix cross product, right? So cross product of vector B comma vector C and hit. So 3, negative 8, negative 1. This vector is 3, negative 8, negative 1. Perfect. Now, so my normal vector is 3, negative 8, negative 1, and my vector A was my vector A. Let's see. Vector is minus 1, 2, 0. So vector R dot vector N is equal to vector N dot vector A. So X, Y, Z dot vector N. What is my vector N? 3, negative 8, negative 1 is equal to 3, negative 8, negative 1 dot vector A, which is minus 1, right? Let's find the dot product. Again, we will go, first we'll copy it, then we'll go to matrix and vector cross product, and we'll go product of this vector comma and vector A, right? and need to hit enter. Minus 19. Very good. We got x minus 8y minus c is, so this is my question. Right. So I hope everything is clear to you. The next classes we will move further on things. And in the meantime, please subscribe to my